In today's lesson, we'll be solving related rates problems. We've been doing just kind of an introduction to what related rates are, and now we're actually going to be solving them. So starting out is just kind of your steps, your plan. So I always suggest that you draw a picture. It just helps you visualize what's going on. Okay, then list everything that you know. So list all of your known, and then make sure you pay close attention to your rates and quantities. So make sure you know, so rates we're always doing like the maybe dr, dt, for example, usually with respect to time. And then quantities would just be like your distances or whatever. Okay, so step 3, relate variables in an equation. So this would be like if we're doing geometry, your geometry formula. And then once you have your equation, then we want to differentiate that equation, that formula with respect to time. And then you just need to substitute in all of your known quantities and rates and then solve. So recap, draw a picture, list out all the things you know, find your formula, differentiate with respect to time, substitute, and solve. So our first example, it first starts out saying a 25-foot ladder is leaning against a wall. So before I read any more, I'm literally going to draw my picture. I know I have a wall, and I know I have a ladder leaning up against the wall to give me that visual. Okay, so the 25-foot ladder is leaning against the wall, and it's sliding towards the floor. Okay, so it's falling, which means this height is decreasing, and then this length will be increasing. Now, this right here is the ladder, and the ladder is not going to change. The ladder is going to stay the same length. So this is a constant. So if the foot of the ladder, so the bottom of the ladder, is sliding away from the base of the wall at a rate of 15 feet per second. So I'm going to stop there for a quick second. I'm going to label this X, label this Y, and label this Z. So what they just said was a rate. Okay, 15 feet per second, and that is the rate here that the ladder is moving away. So this is, that a rate would be dx dt, and that is 15 feet per second. Okay, so how fast, so what's the rate? How fast is the top of the ladder sliding down? So they're asking, what is this rate dy dt? Okay, when the top of the ladder is 7 feet from the ground. Okay, so I just rewrote everything. So here I have, so the distance that the ladder is away from the wall. And okay, the rate that it's moving is 15 feet per second. Okay, the y here, so the length, we're looking at when it's 7 feet high. They're asking you, what is this rate? So we need to find dy dt. And then z, the ladder is 25 feet. And then dz dt, the ladder can't change. The length of it can't change. So it is 0. Okay, so now we have a right triangle. So let's set up Pythagorean theorem. X squared plus y squared equals z squared. Take the derivative with respect to time. So 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, so we're going to have to plug in. We have this. We have this. We're going to solve for this. We know this and we know this. What are we missing? We need to find x. How do we find x? We use the Pythagorean theorem. So x squared plus 7 squared equals 25 squared. So I'm going to just speed things up and do that for you. You should get the x equals 24. We all know how to do that. Okay, now we have to plug everything in. 2 times x is 24. Dx dt is 15. Plus 2y is 7. We are going to be solving for dy dt. And then we have 2 times 25, but that doesn't matter because dz dt is 0. Okay, so let's simplify this down. So you should get this, and then if you solve, just subtract, divide, and we should get that dy dt is negative 51.429, and that is feet per second. So the ladder is falling. When it is 7 feet high, it is at that instant, it is falling at a rate of negative 51.429 feet per second. All right, second example. It says area of a rectangle. So before I read anything else, I'm just going to draw a rectangle. Rectangle, pretty basic, but I'm still going to draw it. Okay, so the area of a rectangle is increasing at a rate of 15 feet per minute. And I think that would be because we're dealing with area feet squared per minute. So that is a rate. It is a rate. So that would, I'm going to just off to the side, right? So the rate of the area with respect to time is 15 feet squared per minute. Okay, so the width is increasing at a rate of 2 feet per minute. So if I say this is W, this is saying that the rate dW dt is 2 feet per minute when the length is 4 feet. So the length is 4 feet, not a rate. Okay, and the width is 3 feet. Okay, so that's also not a rate, so I've just got 3 feet here. Find the rate of the length. Okay, so area of a rectangle, my formula is just area equals length times width. So when I differentiate that formula, I will have dA dt. Okay, this is product rule. So derivative of L of my length would be 1 dL dt, and then so derivative of the first times the second plus the first times the derivative of the second would be 1, and then dW dt. Okay, so now let's plug in everything we have. So so the area with respect to time is changing 15 equals, okay, dL dt, that's what we're solving for. We need to find this, but we know W is 3, so I'm going to write 3 and then dL dt plus, okay, the length is 4 and dW dt is 2. So now I just solve. So 15 equals, so this is 8. So I subtract 8, divide by 3. So we could write that as just 7/3, which you could also divide, get the decimal, which is 2.333. And that is feet per minute. So there's 2 examples on related rates. There's your full video. So good luck with the lesson.